Hello friends, today in the series of laparoscopic surgery, I'll be talking on endovision system. So laparoscopy is all about trolley to table. So trolley means endovision trolley or endovision cart in which we have the monitor, the video processing unit, the insufflator, then you have a light source, and on table you have the hand instrument. So entire laparoscopy is made of three parts. One is the endovision system, which we'll discuss in this chapter. Second is the insufflator that we use for creation of pneumoperitoneum, and third is the laparoscopic hand instrument or instrument that is used in doing this surgery. So insufflator and the hand instrument will be taught in a different chapter in the subsequent series. Today I'll be covering on endovision system. So endovision system. This is the circuit of the endovision system. It comprises of three essential parts. First is the light source. So light source is the source which emits light which help us to see inside the abdomen. Second is the light cable. Light cable is the cable which connects the light source and the telescope. And third is the telescope. It is the actual instrument endovision system that goes inside the abdomen and shows what's there inside the abdomen. Fourth is the camera head. Camera head is attached to the telescope and it processes the optical image that is received by the telescope and converts it into a digital data or digital image which goes further into the video processing unit, and this video processing unit processes the data and then in turn reflects this data and forms an image over the monitor. Light source. Light source has various parts. One first is the bulb, which emits light and then falls over the condensing lenses. This condensing lenses concentrates the light over a single point where you attach your light cable. In between, there is a heat filter which decreases the amount of heat energy that is generated by the light source and minimizes the amount of heat that is transmitted through the light cable. Then you have a intensity controller. With this help of the intensity controller, you can control the intensity of the light that is inside the abdomen. There are various types of light source you can have. One is halogen, and there's xenon and the LED. Halogen was used previously. It was cheap and it had a life of around 2000 hours. So the bulb inside the light source has to be replaced after every 2000 hours of use, and it was an hot source, so you cannot touch the tip of the telescope to any delicate organ as in bowel or any delicate structure, because it will lead to the burn of that tissue. Xenon is expensive, but it is an ideal source of light because it emits light near sunlight, the almost natural sunlight you can sunlight like. So the images which are generated into the monitors are almost near natural, and but the problem is the life cycle of the xenon bulb is only 500 hours. So you have to make frequent changes of the bulb around 500 hours. So it makes the instrument this thing light source a little costlier. Latest, we have an LED light source. It's a most commonly used light source. It's cheaper. It is a cold source of light. That means the heat generated over the tip is minimum. Word of caution: though it is a cold source, but you should always avoid a contact of the tip of the telescope to some important delicate structure like bowel or any ureter or a CBD, because this is going to cause some amount of burn. It is near sunlight like light, and it has a very long life hour, that is 50,000 hours of life, so you don't have to change the bulb so frequently. Light cable is basically the connector between the light source and the telescope. There are two types. First is the fiber optic cable and second is gel crystal cable. Fiber optic cable is the most commonly used cable as it is cheap, but it is delicate as it has very thin glass fibers that are incorporated in a bunch of the cable, so that can be easily broken with multiple uses and poor manipulation, proper manipulation, not proper handling. So over the time the intensity of this fiber goes on decreasing, so you have to replace. but still you can work with a broken cable to some extent. Second is the gel crystal cable. It is costly as compared to the fiber optic cable. It is very flexible as compared to the fiber optic cable. The problem is it contains a liquid inside the sheath. If there is a small cut over the sheath, then there will be leakage of the fluid and this cable becomes useless. You cannot use it anymore. So even a small pinpoint break into the sheath will lead to the leak of the liquid, and the cable becomes useless. Next component of Endovision system is the telescope. Telescope has various parts when you see from outside. One is the eyepiece. This is the eyepiece where your camera head gets connected. Second is the light source connector. This is the area of light source connector. You can appreciate this is the area of light source connector, and the rest of it is called as the endoscopic body. When you take a cross section through the endoscope body of the telescope, we can see this configuration. This was the initial glass lens endoscope that was used for laparoscopy in initial days. So these are the lenses, biconvex lenses with equal distance, and the space was filled by air. So the problem was conventional telescopes were they had lot of distortion of the image. Second thing, the image was not that clear. But after the advent of after the invention of Hopkins rod lens system, this system was replaced by rod lenses with minimal spaces in between, and even this spaces was vacuum was created. So the image of this was made more clearer and more there was minimal diffraction of the images. On internal part examination, one is the rod lens system, and at the periphery you will find, or at the top you will find the optical fibers which emits light inside the abdomen. So you can see the arrangement here. This is the for the light fiber cable. Here also you can have various arrangements. Even in this you have a different type of arrangement for the optical fiber. There are various types of the telescope you can have. It sizes and angles. So in sizes you can have 2 mm, 4 mm, 5, 10, 12 and even 15 mm diameter telescopes. But the most commonly used telescopes are 5 and 10 mm telescopes. Angle telescope means it will have an angle at the tip of the telescope. So you have a 0 degree, 30 degree, 45 degree, 70 degree, 90 degree, 120 degree. So there are various angles at which can have. But the most commonly used telescope is 30 degree. There has been a color coding. If you have a 0 degree, you will have this line where you have a light connector. So you will have a green band around this that suggests it's a 0 degree telescope. Either it may be 5 mm or a 10 mm diameter telescope. But if this color coding is there, that suggests it's a 0 degree. And in a red, if there is a red band, that suggests it's a 30 degree telescope. Most commonly used telescope is the 10 mm diameter and 30 degree telescope. A point of special mention is of multi-view rigid telescope that was manufactured by Carl Store's company. It has a camera or the lens at the tip can be articulated to show images from 30 degree to up to 120 degree. So there was a simple knob that has to be rotated to change the viewing angle of this telescope. So you can appreciate this. This is the 30 degree telescope view. Then this is the 70 degree telescope view. Then third, as you increase the angle, the amount of vision or the amount of structures you see. This is the spleen in the porcine model. So you can see the spleen is appreciated better. So accordingly, depending on the structures you need to see or the area you need to see, you can change this. But this was not well popular because it adds a lot of cost to the instrument. Plus, the utility of this instrument was not that great. So 2D image versus 3D image. We have a different telescope for a 2D and a 3D. So this is a typical 0 degree 3D telescope which has two rod lens system, as you can see, as compared to the 2D conventional telescope which we have. This is a 0 degree 3D telescope and this is a 30 degree 3D telescope, and this is 30 degree 2D telescope. What are the parts of the CCD or the camera head? So first part is the coupler. Coupler is the area where your telescope's eyepiece fits. Then you have a rotating knob. These are the rotating knobs. You have rotating knobs for two things. First is zoom in and zoom out function, and second thing is to focus the image. Then at the back you have a video sensor. The image from the telescope is projected through the coupler, through the what you call the rotating knob over the video sensor, which converts the optical image into a digital signal and then transmits it to the video processing unit. Camera head is basically called a CCD, that is charge coupled device. It has evolved over time. Initially it was single chip camera which had a little less clarity and contrast ratio was also less. Over the time it has evolved from single chip to three chip, which improved quality, clarity and the contrast. Now we have an HD, high definition, 4K and even 3D telescopes. A technology like CMOS has come up in a better way to increase the further clarity and stability of the image. So the image which we see is normally made of two things. One is luminance, that is the brightness, and second is chrominance, that is the color. So you have a red, green and blue color. Together this image will give you the exact image which is formed. This is the video processing unit which receives the data from the CCD or the camera head. It processes this data and then projects it over the screen. That is the monitor. Monitor, initially we had a CRT, that is cathode ray tube monitors with little less clarity. It was measured, that clarity of this or the quality of the screen was measured into horizontal lines. Then came the era of LCD, that is liquid crystal displays, which was little better, a better clearer image and flatter screens. And the latest we now use a LED, that is the light emitting diode, with a better improved 4K quality, which enhances the vision of the surgeon. Even the small capillaries present over the structures can also be visualized better. The medical grade monitors are slightly different than the conventional 4K TVs which you have at your home, because they have a better color luminance, I mean color clarity, better depth perception. Second is the contrast, the contrast enhancement, and the various shades of grids are different. So you see organ very differently as compared to the TV and much clearer, and it produces least strain to your eyes. Thank you for listening. For any queries and questions, you can ask in the comment section. Thank you.